Hi, in this video I want to talk about TopFix within the MTS simulation software. TopFix is going to allow us to create custom work holding solutions within our simulation. So let's just say we've got a milling project and I've selected this housing that we want to mill, and we're gonna probe the bore to set our work offset. And drill these 4 holes in this housing. We're going to lay it on our side. So we need to do a simulation project that brings in this housing, and we need to be able to hold it in something, and it's going to probably be a little unique to be able to hold this odd shape. The first thing that I do is I went ahead and I created a coordinate system where I want my workpiece origin to be. That's going to make our life just a little bit easier when it's time to do the setup in the simulation software. So I created a coordinate system number 1. And then we went ahead and we saved it as an STL. So when you save a file out of SolidWorks or out of your CAD system as an STL, you can choose what coordinate system to output. I outputted it via coordinate system 1, the coordinate system that I had chosen. And I said, do not translate the output into positive space. Leave the positive positive and the negative negative. So I went ahead and saved that STL file in a place where I could find it, and then went ahead and started my simulation project. So for this project, again, I used the Haas vertical mill. This one is a Haas controller just for this project. And I started a simulation project that I labeled housing. So we'll go into the simulator with that housing project. And this is just a standard setup. It came in with a vise and a block of material. So we want to make those changes, and we want to set it up using our TopFix system. So I'm going to go to the setup. The first thing that I'm going to do is go to my workpieces and clamping devices and switch it from a cuboid to a prefabricated part. And I had saved the prefabricated part in my InCAD folder, and I called it housing, and it's an STL. Remember, we saved it about that coordinate system number 1. So now we've got our housing is our workpiece, but the vise really isn't a realistic work holding. We've got some issues here with different depths and things like that. So we're going to switch from the vise to a modular clamping system. So next in the workpiece clamping, I'm going to select modular clamping system. That gets rid of my vise, so we're just kind of floating in air now. And I'm going to go into TopFix by pressing the button TopFix. Now you can see the table of the machine is highlighted red. Whatever is red is the marked component. That means when I build modular components, they're going to build upon that. If I hold the control key and click on my workpiece, that becomes red. So red shows us that that's the marked item, and we're going to be adding to that. So I'm going to go ahead and control and click on the table of the machine so that I can build up from there. And then I'm going to start with this icon, add a clamping device. We've got a couple of different options. I'm going to say TopFix. We're going to go into the TopFix, and I'm going to choose a building block that I can set this housing on. You can see there's clamps and clamping units and stops and all kinds of things. There's even bricks there, Legos. If you want to do a neat Lego project, you can build up in Lego. So we're going to say building blocks, and we need a height spacer. And I'm thinking we're going to need, we'll go about 3 by 5. Maybe 3 and 9/37. So I believe this is going to be a 135 millimeter by 85 millimeter by 100 millimeter high. So we'll use that. That'll be a good spacer to set this guy on. So that comes in, and now you can see the yellow lines that are on the table. Those yellow lines are areas that we can snap to, basically. So if I hold down the space bar and then click on the center one, that moves my clamping device over to the center T-slot. And now I'm going to just move, you see we have our Y and our X and our angular. I'm going to just move my X position over to where it's underneath there. And I can hold Shift and then hold the X down, and it'll move it a little bit faster along. Also, if you know the center of your table, you can key the number in. I don't know what that is, so I'm just going to free slide it along the center key slot until we're underneath our workpiece. Not too bad. And now I want to bring my workpiece in contact with the top of this guy. So I'm going to hold the control key, mark the workpiece, move it in Z positive until it's above my, see there's a little air gap there, it's above my, my work holding device. Let's go a little more just to make sure. There we go, now we can see some air gap in between. I'm going to turn my collision test with workpiece on and then move Z back down until it makes contact. So now my housing is sitting right on my little riser block here. Now I want to bring in a couple of clamps to hold it down. So I'm going to control and mark the table again. TopFix. And I'm going to use a clamping unit. How about one of these gooseneck clamps? Looks like we have one that fits this scenario, that fits the size, so I'm going to accept that. And I'm going to hold down the space bar, click on the center, move it in X position. Remember, holding shift will speed it along a little bit. So we've got a little collision there. I had left my collision with the workpiece on. And we need to raise that clamp just a little bit. And I think if we do the clamping right there, we're putting pressure pretty much off center. So let's rotate this clamp by about 10 degrees. So we'll change our C position. I think -10 might go, yeah, there we go. Now that gives us a little bit better angle on that part. Let's raise the clamp just a little bit more. And then let's slide the clamp inboard. Inboard, not outboard. There we go. Pretty good. We can even go just a little bit more. And now I can bring the clamp back down until it makes contact. There we go. So now we have a clamp on one side of the workpiece. And I want to duplicate that same clamp on the opposite side. So I'm going to choose the third icon in, says duplicate. Pretty nice because when you hover over all these icons, they tell you what they are. We're going to say duplicate. So that gives me another one of those clamps. I'm going to put it over here. And we're going to say this is going to be about 170 degrees, I believe. Oop, 190 degrees. There we go. So they're both canted about 10 degrees. And now let's slide them in the X direction. There we go. So now we have our two clamps holding our housing in place on a little riser block. Pretty happy with that. I'm going to say OK. Now we have a new setup. And what's nice about this is the clamps are all recognized for collision. If I should happen to touch my probe or my drill or holder or something like that on those clamps, it'll tell me. If I drill too deep and get into the riser block, it'll tell me. So very good. And then zero register. And remember I said it'll make our life a little bit easier to save this STL about coordinate system number 1. I'm going to just choose from my drop down work part 0 point. That puts my G54 location. I use G54 on this program. My G54 location right at the top center circle. Pretty happy with that. So now I've got a little more realistic clamping situation. We've already written a little manual program here that will put a probe in the spindle as tool number 1. We'll probe the center and update our work offset, and then just come back and drill the 4 holes. So we'll go to automatic mode, make sure my collision detect is on, take it off from single block, and go ahead and probe that hole for our location and update our work offset. You can see as the probe is running, we're updating our macro variables as the probe runs, and then we'll come back and find the holes and drill those 4 holes. Very good. Now we have an accurate simulation. If this is the clamping setup that is used on the shop floor, we know we've accurately simulated to make sure we don't have any collisions or any problems. We can send this clamping setup out to the shop floor so that they can follow it, and we should expect the same success out on the shop floor. I hope you've enjoyed it and learned a little bit about TopFix. Thank you very much.